my name is Carolina Soto, and today I will be talking about the bubonic plague. So what is the bubonic plague? So the bubonic plague is an infection caused by the bacteria Yersinia pestis, and it is an infection that specifically targets the lymphatic system, which causes inflammation of the lymph nodes. And before we begin, I would like to read this quote from Giovanni Boccaccio, who was an Italian poet and writer that lived during the second pandemic of bubonic plague. So of the Black Death, he says, "How many valiant men and women, how many fair ladies, breakfast with their kinfold, and the same night souped with their ancestors in the next world." So the reason why I chose this quote was because it shows how men and women are susceptible to the bubonic plague. And this is true of all ages. And also in the last part, I believe that it perfectly describes how death can happen quickly after infection, so how infectious this disease actually is. So bubonic plague is one of 3 types of plague caused by the bacteria Yersinia pestis. So Yersinia pestis is a gram-negative, non-motile bacillus bacterium that infects humans via infected fleas. It was discovered in 1892 by Alexander Yersin, as shown here, and he was a Swiss-French physician and bacteriologist from the Pasteur Institute, and he actually discovered the bacteria while he was studying an outbreak in Hong Kong, and he was able to link the plague with the bacillus, and he named the bacteria Pasteurella pestis. However, it was renamed in 1944 as Yersinia pestis in his honor. So the 2 other types of plague are septicemic plague, which is when there is infection in the blood, and then pneumonic plague, which is when there is infection of the lungs. So here we have the taxonomy of Yersinia pestis. So as you can see, the bacteria belongs to a family known as Enterobacteriaceae, which is a large family of gram-negative bacteria that includes pathogens such as Salmonella and E. coli. So the genus is Yersinia, which consists and includes ovoid and rod-shaped bacteria. And lastly, the species is pestis, so Yersinia pestis. And this image is actually in a scanning electron micrograph depicting a mass of Yersinia pestis in the gut of an infected flea. So here, next we have the timeline of the bubonic plague. So Yersinia pestis has been discovered in archaeological finds from the late Bronze Age, and it was identified by the DNA in human teeth. So it is thought to have been around since 3800 BC. Next, we have the first reported epidemic, which was the plague of Justinian. It was thought to have killed perhaps half the population of Europe at the time, and it afflicted the Byzantine Empire and Mediterranean port cities. Next, we have the Black Death, which is the pandemic that I believe most of us are aware of. And it was the second pandemic that occurred in the late Middle Ages, in which Europe, Asia, and Africa experienced the deadliest disease outbreak in history. So after plague reemerged in then we have 1892, which was the discovery of Yersinia pestis, when Alexander Yersin was able to link the plague with bacteria. And lastly, we have the third pandemic, which was when plague reemerged in a remote Chinese province, and it spread to Hong Kong and then later Bombay, and it reached ports in every continent. So next we have pathogenesis, and the cycle of infection begins with fleas, particularly Xenopsonotropis, which is the oriental rat flea. It's this one depicted here. And the infected flea forms a biofilm inside the foregut of the insect that appears as a black mass. And you can sort of see this in this image. And these fleas live on rodents, which are the bacteria's main reservoir. So these rodents include marmots, prairie dogs, ground squirrels, and of course rats. And this is primarily the brown rat. So when the flea feeds on the host, the biofilm and bacteria are regurgitated onto the wound, thus spreading infection. So we have the bite. The flea essentially vomits on the wound, and the rat becomes infected. However, the flea is parasitic to the rat, so eventually the rat dies, and the flea is left to find a new host, which is where it becomes dangerous for humans. So, same mode of infection, the flea bites a human and it regurgitates the biofilm as well as the bacteria into the wound. And here is where we begin the pathogenesis in humans via the flea bite. So once the bacteria is inside the body, neutrophils and macrophages come to the wound site to kill the bacteria. Now the bacteria has this capsule, which consists of capsular antigens called F1, as well as anti-phagocytic properties. However, whenever the bacteria is inside the flea gut, it loses the capsule. So it makes the bacteria susceptible to these neutrophils, who are able to attack the bacteria. However, these macrophages, they are not as efficient in killing the bacteria, so the bacteria is able to survive in them after they are engulfed. So inside these macrophages, the bacteria uses various virulence factors, and it is used to help the bacteria survive. So one of them being that the capsular antigen F1, as seen here, which forms that capsule that protects the bacteria, it is produced inside these macrophages. So you have that protection within the macrophage. And it also has a type 3 secretion system, which is essentially a collection of bacterial proteins that lowers the host immune response. And these type 3 secretion systems, they secrete, and you can sort of see this here, these yellow dots on the macrophage coming from the bacteria. They secrete Yersinia outer proteins known as YOPs, which inactivate other macrophages. So this leads to the evasion of phagocytosis. So they're able to bypass and trick these other macrophages into not phagocytizing them. Also, these macrophages produce a siderophore known as Yersinia bactin, which essentially goes and looks for iron and returns it to the macrophage so that the bacteria can thrive and replicate. So iron is really important for bacterial replication. So these macrophages then carry the bacteria to the lymph nodes where they replicate, and they cause lymphadenopathy. So this is the inflammation of the lymph nodes, and we get those swellings known as buboes, which is where bubonic plague gets its name. So eventually the macrophage bursts and allows for the bacteria to spread throughout the body. And just like that, you now have bubonic plague. So symptoms begin 24 hours to 4 days after becoming infected, and they include fever, headaches, vomiting, pains in the abdomen, arms and legs, the limbs, as well as the characteristic swollen lymph nodes or buboes, which occur primarily in the inguinal and axillary region, so in the armpits and near the groin. And bubonic plague can be diagnosed by isolating Yersinia pestis using blood and tissue samples. So this bacteria is isolated from blood, buboaspirate, or sputum. And it can also be identified using staining. So the bacteria is identified in a peripheral blood smear using gram stain, Wright Giemsa stain, or Wason staining. We also have the use of serological tests, which essentially confirm diagnosis. And what happens in these serological tests is that we are looking for a 4-fold increase in antibody titer between two serum probes taken 2 weeks apart. Lastly, we have a rapid antigen test that is seen on the far right. And this rapid antigen test, it identifies the F4 antigen that is part of the capsule in the sputum or serum of a patient, and you get your results in 15 minutes. So next we have management and treatment. So how is bubonic plague treated? So immediate treatment is critical since the incubation period is between 1 to 4 days. And the bubonic plague luckily, can be treated and cured with antibiotics such as aminoglycosides, including gentamicin and streptomycin. We have tetracycline and doxycycline. We have fluoroquinolones, which are a class of potent antibodies that consist of ciprofloxacin, miofloxacin, and levofloxacin. Ciprofloxacin, levofloxacin, and miofloxacin. And lastly, we also have chloramphenicol, and these drugs are either administered by mouth or intravenously for a period of 10 to 14 days. And as mentioned above, these antibiotics, primarily chloramphenicol and streptomycin, they have been used to treat bubonic plague, but they are not widely available in the United States. Also, in the United States, there is no bubonic plague vaccine, but in other places where bubonic plague is endemic, there are vaccines available. So what happens if bubonic plague is not treated? So if bubonic plague is not treated, it can be fatal because it can lead to infection of the blood, which is septicemic plague, or infection of the lungs, which is pneumonic plague. And septicemic plague and pneumonic plague are both develop from a progression of bubonic plague. So septicemic plague actually has a 95% death rate, while pneumonic plague has a 100% death rate for those infected. And the reason why pneumonic plague is particularly dangerous is because septicemic plague and bubonic plague both have the main form of transmission is from that vector, from the flea. The flea bites the person and they become infected. However, with pneumonic plague, there is a shift in the mechanism of transmission, which is aerosol inhalation, or it becomes airborne. Treatment, septicemic plague and pneumonic plague are both fatal. So bubonic plague turning into those two other types of plague will result in death. So bubonic plague today. Every year there are thousands of cases that are reported to the World Health Organization. And luckily, with proper antibiotic treatment, the prognosis for victims is much better than before antibiotics were developed. However, the closest thing to an endemic that has occurred was during the Vietnam War. There was a 5 to 6-fold increase in cases during the war, primarily in Asia. And this was most likely due to the disruption of ecosystems in which humans were in close proximity with rodents, and those fleas carried the bacteria. So today, the plague is commonly found in sub-Saharan Africa and in countries such as Madagascar, as well as the Democratic Republic of the Congo. And these areas now account for 95% of reported cases. And recent statistics have shown that from 2010 to 2015, there has been a total of 3,248 infections, resulting in 584 deaths. And lastly, we have some quick facts about bubonic plague that I found interesting. So bubonic plague has an R naught of 3 to the second, so 9. Second is that of plague doctors. So during the bubonic plague, or the Black Death, doctors wore these bird-like masks to avoid becoming sick, and they would shove spices and rose petals into the beak so that they wouldn't smell the rotting bodies, and also they thought it was to prevent getting the infection. Next is this image of a catapult, and the reason why is because bubonic plague has been used in biological warfare. So one of the first recorded uses of biological warfare occurred in 1347, in which Mongol forces were reported to have catapulted plague-infested bodies into Kaffa. Fourth, we have flagellants, which is where some people thought that the disease was a manifestation of God's revenge. So this religious group would whip themselves while praying for forgiveness, and they would try to ward off the plague in this way. And lastly, we have cats. So believe it or not, cats are actually highly susceptible to plague, and they are the common source of Yersinia pestis infection in humans to this day. And lastly, we have the sources, and thank you for watching.